All right, so this is going to be a fairly full video, especially for your first split video, because we're going to talk about all operations with fractions. Another word for fractions would be rational numbers. We'll talk more about what makes a number rational or not, but right now we'll just refer to them as fractions. So before we get into the actual operations mean addition, subtraction, multiplication, division, this is supposed to be entirely a review. We need to make sure that you have the skills for fractions, just kind of reminders of them, because you're going to be needing to be able to move between mixed numbers and improper fractions. So skills for fractions, remembering that to go from this mixed number to the improper fraction, you need to, this is 2 full sets of 7, and then you only have 3 left over. So how do you figure out how many sevenths you have in an improper fraction form? You multiply 2 times 7, and that's what this is supposed to be, an arrow, and you add 2 times 7, 14, plus 3, 17, to get 17 sevenths. How do you go the other way, improper fractions to mixed number? You say, okay, how many times does 5 go into 24? Well, the answer is 4, so that's your unit number, your large number here. And then what about leftovers? What's the remainder? The remainder in this case is also 4, so that's the numerator for how many fifths you have. So 4 and 4 fifths. So just reminders about these skills. Other skills for fractions you need to make sure you're always simplifying. It's just an easy thing to forget, but look for what numbers can divide both these. So in this case, I'm going to say, okay, I know 2 right away, so that's 6 and 63. Well, is there anything left? Yeah, there is. There's a 3 that can divide both of them, both numerator and denominator. So you want to make sure you simplify. So those 2 things are just guiding principles for everything we're going to do. So when it comes to the first 2 operations, adding and subtracting fractions, assuming you've got down your how to add negatives, subtract involving negatives as well, to remind you of your steps. When you're talking about adding and subtracting, it's common denominators, only with addition and subtraction. So step 1, find your common denominator. So probably more likely you're going to do this in your head, but you're going to figure out, what could I turn both of these numbers into? What could I turn this denominator and this denominator into using only multiplication? So I need to think of my multiples of each number. 4, 8, 12, 16, 20, 24, 28, 32, 36. Once I come to the smallest number they have in common, that's my common denominator. So step 2 is make equivalent fractions with that number as your denominator. So we're going to take the first fraction, 7/9, and how do we turn that into a denominator of 36? We multiply by 4 and multiply by 4. How do we take the second fraction? We take it and multiply by 9. So equivalent fractions, 28/36 is the same as 7/9 as far as value, and 9/36 is the same value as 1/4. So we're going to make equivalent fractions for step 2. Step 3, add the numerators. So 28 and 9 is 37, and keep the denominator. So if you remember, like as far as addition and subtraction of fractions, why that is, like think about if you add 1/4 plus 2/4. Think about what the answer is here. It's going to be a total of 3 out of the 4 pieces are filled in. So you add the numerators or subtract them depending on what the operation is, and keep the denominators. Step 4 is simplify. For our purposes, 37/36 is simplified. That's a fine answer. If you want to change it to 1 and 1/36, that's fine too. Either one works. Not both. You don't have to have both, just one or the other. So this was my kind of I do. Now it's your turn for you to try. So you're going to pause the video. After remembering that it's really going to be helpful if we take mixed numbers and change them into improper fractions before you start. So try these two, pause, and then come back to the video. So for this one, this is really 17/8. So if we have 17/8 and 5/6 being added together, we can turn both of these into a denominator of 24. So that's 51/24 and 15/24, which gives you 66/24. Oh, sorry, now I just saw the mistake. I was wondering about that. I didn't multiply by 4 there. I multiplied by 3 instead of 4. So this should be 20, which makes this 71/24. 71 and 24 have no factors in common. I can't divide either of those by the same number. So I could leave that answer, 71/24, or it's equal to 2 and 23/24. Either one of those would work. For the second one here, 2 and 1/5 is really 11/5. So this is 4/7 minus 11/5. The least common denominator would be 35. So times 7 and times 5 would be 20/35 minus 77/35. So that gives me, if I do 20 minus 77, 35 is my denominator. 20 minus 77 would be negative 57. Just double checking myself. Negative 57/35, and 57 is a prime number. So that's an answer. Or negative 1 and 22/35 left over. Either one of those answers would be acceptable, but just reminders about our fraction operations there for addition and subtraction. Moving on to multiplying and dividing, I just want to relate this back to what you've known for a long time about multiplying. Think about how we multiply with whole numbers. Think about how we divide with whole numbers, even if you're going to talk about fractions. So 3 times 4 is 12. Well, let's think of, okay, how would I turn each of those into a fraction, and maybe that can help me with fractions in general. Well, if I do 3 as 3/1, 4 as 4/1, it can kind of help me see that to multiply fractions, what do I really need to do? 12 is 12/1. Really what I'm doing is multiplying your numerators and then multiply your denominators. So it's just a matter of straight multiplication. After that, this is the easiest operation for fractions. After that, if I would list a third step here, I would say simplify. The thing about that third step, though, it could actually come at the very beginning. Because if you remember, when it comes to multiplying fractions, you actually can do your simplification at the very beginning, because it's like when I'm going to multiply, I'm actually going to just multiply the numerators and the denominators here. I can actually do my canceling early on. So sure, 2 and 9 don't actually cancel, but if you look at the 3 and the 9, we call this cross canceling. Well, what can I divide both of those by? I can divide both of those by 3, and then perform my multiplication. Does it really matter when you do your canceling? No. It just may end up being easier at the beginning. So multiplying fractions is pretty straightforward. What is less straightforward is the division. So again, I said let's focus on whole numbers first. What does division actually mean? What does it mean to take these 6 circles and divide it by 2? Well, it could mean to divide it into groups of 2. And the answer is how many groups I can make. That's one way that you can look at what division is asking you for. So how many groups of 2 in the 6 total? So what if we do the other way? What if we start throwing fractions in? Well, we can ask the exact same question, just a different solution here. So how many groups of 1/2 are in 6? Well, if only one, If only 1/2 goes into a group, well, here's a half. Here's a half. Here's another half, and I know that box isn't drawn very well. Here's another half. There's a half. There's a half. We take each of these and we split it in half, and it only takes a half to make a group. Well, how many groups do I end up with? I end up with 12 groups. Okay, so how can I get that from actually looking at the operation and not having to draw it out? Well, it's our good friend, our Indian Hills anyway, good friend phrase, keep it, change it, keep it, change it, and flip it. So we keep the first number, and I'm going to put it in fraction form. We change the sign from division to multiplication because dividing by a number is the exact same thing, excuse me, as multiplying by the reciprocal. So flipping it is another word for reciprocal. So flip it, numerator becomes denominator, denominator becomes numerator. And then we've turned it into an easy multiplication problem. So dividing fractions, you can see a little bit of intuition about that. So that was my my I do, the multiplication and division. Now here's your chance to try. Again, just like with the addition subtraction, the best way to handle these problems is going to be to put them in from mixed number into improper fraction first. So pause the video and try this one, and then check your answer. So negative 1/2 becomes negative 3/2 divided by, and 4/9 stays the same because it's just a regular fraction, no improper. Okay, so now to do the division, we have to keep it, we change it, and we flip it. We don't want to, and one of the mistakes people will make is trying to cancel when it's in a division problem. You cannot cancel until you have it as a multiplication problem. So you may have been tempted at that point to start cross-canceling, but that only works when we're talking about multiplication. So if we're looking at this, we have a negative times a positive. We have a negative times a positive. Our answer is going to be negative. Same signs have positive answers when multiplying or dividing. Different signs have negative answers. So if we multiply here, we multiply the tops. 3 and 9 is 27. Multiply the bottoms. 2 and 4 is 8. So the answer is negative 27 over 8, or negative 3 and 3/8. Either one of those answers would be more than acceptable. No simplifying necessary. So this was a review of operations with fractions. We will practice in class tomorrow.